I'm Chandana Mitra, and I'm an associate professor in the Department of Geosciences at Auburn University in Alabama. By training, I'm a climatologist and I'm also a physical geographer. What I do is, mostly on the lines of physical geography and climate change, is I look at the growth of urban areas, the growth of cities, how big the cities are growing, and what kind of impact the cities have on the microclimate, the local climate around the cities, and how it impacts humans. So my research is mostly urban-centric, so city scale. So what I look at is, in the beginning, I begin with how a city's shape and size and structure changes over time. So we use a lot of satellite images and historical maps, old maps of cities, and try to quantify and delineate the growth of a city, say from past 20 years to 50 years, and how they have grown up to the present times, like how a city looks today. And after that, what we do is we have these images and we put them into these computer models. They churn inside and they spit out how a city is going to look in the next 20 years, 50 years, 70 years. And so why is that important? It's important to understand how a city is going to look in the future is because we know that cities have a lot of population, there's huge amount of migration, people come in, and because there's huge amount of population, so we emit a lot of gases, a lot of air pollution increases. Then a lot of anthropogenic activities, which is human activities, are always on the rise. So we generate a huge amount of energy, heat. It does impact, the way we move around, businesses come in. So all these activities, which transforms natural surfaces to unnatural surfaces or concrete, that is what my major research is, trying to quantify, to understand what are the changes which are happening. So after finding what the changes are, the next phase comes in where I start to quantify and trying to get data, collect data, and some of which are very primary data, which are used to understand what the temperature differences are between an urban area and the surrounding rural area. So every single city, be it small, medium, or large, it can be even Manhattan, Kansas, it can be Lawrence, it can be city size going up to New York, or Atlanta, or Los Angeles, or any other big cities of the world. What happens is they constantly generate a lot of energy and heat, and that is referred to as the urban heat island intensity. So generally between 5 to 7 to 12 degrees Fahrenheit, which would be around at the scale of, again, 7, 8, or 12, 15 degrees centigrade, because the rest of the world uses centigrade. So that's the difference of temperature between the urban areas and the surrounding rural areas. And that is known as urban heat island. Now you would ask, why is this whole urban heat island so important? Now the thing is, temperature drives a lot of these different other whatever goes around in our lives. If there's more air pollution and the temperature is high, it is more detrimental for human health. If the temperature is high, then we are going to have crank up our air conditioners, and that uses a lot of energy. And where does the energy come from? It comes from, burning up fossil fuels, which again adds to the greenhouse gases. And that translates to climate change. So you can see how it's a domino effect. So urban areas churning its own energy and, the air pollution, all the black roofs and the dark asphalt and, the concrete, all of that generates energy, soaks in a lot of energy. And so that adds on, or that kind of translates into this bigger picture of climate change, which is obviously a global phenomenon.